and share screen. So share, and here we are. All right, so this is a normal distribution. There's a formula for it. It's not interesting. We got to remember that in this book, it's gonna look something like this. It's gonna say the random variable x is normal with a mean and a variance. You got to remember that the second number is a variance. Now, this here is a very specific normal distribution. We call it a standard normal distribution. And a standard normal distribution has the following. It's normal, the mean is 0, and the variance is 1. When you take the square root of 1, the standard deviation is 1. Very important to remember that. Now, what does this depict? See, it says whatever z-score here, this is the area, right? So that's what we got to remember. That the areas given here are going to be areas that are to the left of a z-score. Another thing that's interesting about this table is the fact that it only has positive z-scores. Now, here in the middle, we have a z-score of 0. Now, if we got to remember, and again, some of you haven't taken statistics, but some of you don't know what a z-score is. A z-score is simply how many standard deviations a particular score is from the mean. That's all it is. That's all it is. So here in the middle, we have a z-score of 0. And if you think about it, if we know the area under a curve is 1, what do you think is the area to the left of z equals to 0? It's going to have to be how much? 0.5. It's half of the graph. Remember, under any density curve, and a normal distribution is a type of density curve, the area under the curve is 1. Therefore, half of the curve will have half the area. Now, if we take a look at a z-score of 0.0, look what area states there. It says 0.5. 0.5. That's the area that's stated there. As you increase your z-score, for example, can somebody tell me what 0.01 z-score area is? So 0.01, 0.5040, 0.02, 0.5080, 0.03, and so on, right? That's what it is. Now,
so z-score would just be like the z, like 1, z2.
yeah, well, here's what I should
See it in the
yeah, look.
0.00.
So yeah, like around here, we would say this is a z-score of 1. Around here is a z-score of 2.
Okay.
All the way out here would be a z-score of 3. So again, some of you guys have never taken statistics. And for the sake of brevity, I have to do like a cliff notes of this. Now, this table only reads positive z-scores. Well, we also have negative z-scores. Okay. But before I do that, I want to make sure you know how to read this. Can you please tell me what the area to the left, the z-score, for a z-score of 0.34? So the area to the left of a z-score of 0.34. So here's 0.30, 0.31, 0.32, 0.33, 0.63, 31. Now this is depicted as follows. If I were to draw a normal curve like that, I know the middle here is 0. I know here like around there is 1. We call this here like the inflection point when there's a change in concavity between a negative concavity and a positive concavity, I would say that 0.34 would be like around here. So Z is 0.34. Okay. Now, that there is telling me that the area depicted there is going to be what? 0.6331. So this area here is 0.6331. Super simple. Now, we also refer to this as the phi of 0.34. The phi of 0.34 is equal to 0.6331. The phi of 0.34 basically is the probability that Z is less than or equal to 0.34. That's what phi means. So anytime the book says phi this, phi that, it's just saying, give me the area to the left of 0.34 or whatever Z-score is being mentioned. That's all it's saying. That's all it's saying. Now, what did I say was the area of the whole curve? What was it? 1. Now, if I wanted to figure out this piece here, how would I figure the area to the right of any Z-score? Does the table give me areas to the right, or is it always areas to the left? The table only gives me areas to the left. So how would I figure out that piece to the right? If I know the area of the whole curve is 1, and I also know that the area to the left is 0.6331, what we do? 1 minus 0.6331. That's, so it's 0.3, what? That's what the area to the right would be. Does that make sense? That's super important that you realize how we achieve that. In other words, if I were to redraw this, and I asked just for this area here to the right of Z, then you would have to figure out that the area to the left here was 0.6331. So therefore, the area, the probability that Z would be greater than or equal to, you could write, I'll just put greater than 0.34, must be equal to 1 minus the phi of 0.34, or 1 minus 0.6331, which is 0.3669. Does that make sense? Is that super difficult? I don't think so. Now, what I also want you to realize is that you can also have negative Z-scores. For example, I could have asked you the following. Hey, erase that because that looks really ugly. I could have said, what's the phi of negative 0.34? I could have asked you that instead. Right? Now that's a really bad depiction of 0.34. Let me go ahead and fix that for a second. The new update on Microsoft Whiteboard is no good, so I still haven't downloaded it. Should be like around here. So what's phi of negative 0.34? So I draw the situation now. Here is The middle here is 0, so negative 0.34 is like around there. Okay. And the phi of that is to the left there. Now, does the table give me that? It does not. But if you notice something, this here has to be equivalent to that by symmetry. Therefore, the phi of a negative z-score is just going to equal to 1 minus the phi of the positive 1. That's all it is. That's how you figure out the phi of a negative z-score. It's 1 minus the phi of a 0.34. And as a consequence, if I wanted to figure out what's, and I'll just write it. If I wanted to figure out this part here instead, what if I wanted this part? It would just be the phi of 0.34. Because if I take one, whatever I got here, because you guys know that right here, I'm going to get 0.3669. If I want to figure out this piece here, it'd just be 1 minus 0.3669. But what's that? Well, that's 0.6331. So as long as you remember that, you can tackle a bunch of different problems associated with normal distributions. Now, we're almost done, but before I just, and did everybody write that down? I mean, I'll put the notes up there, but I'll wait because some of you are writing. Before I'm done with that, we still need to extend this a little bit further. And there's still slight technicality on how to read this table for further decimal places, because usually we can do tenths and hundreds, but in this we can go further. We can go to the tenth, hundreds, thousandths. I can't pronounce it. Thousands place. Okay. So that's all fine and dandy, but we can also do more. For instance, what if I wanted to figure out the area in between two z-scores, for example? Let's say I want to figure out the area between 0.34, and these are z's, okay, and 0. How would I figure out the area? I'll do that in another color. Might as well do it. The area in between a z-score of 0.34 and 0. Well, let's see. Yeah, you find both and you subtract. So just to give you, just to make it visual, you know what? Let me be kind of like cool about this. So there we have that. So let me go ahead and lasso that. No, you know what? Let me go ahead and, oh, no, there. I want to lasso that. I'm going to make 2 of them. Copy, paste, paste. I got to move this guy though. Let me go ahead and, how do I move that? You know what? I won't move it. I'll just paste it here. And it didn't move it. Look how this looks. It's horrible. Ah, there we go. There we go. And I can delete this guy. Wait. Okay, so there we go. So I have 3 graphs there. So I want to find the area in between 0.34 and 0. These are z's, okay? So I want this area here. If I looked up 0.34, the area it would give you is all this here, which is 0.6331. Here's the area for z equals 0, keep consistent. It says that it's gonna be 0.5. Pretty at least. But I don't want those two areas. I want the area in between it. I should have, let me drag this a little bit to the left. So it aligns a little bit better. Now notice something. Notice that if I just erase this piece here, and wait, let me align that too, because then that won't come out nice. So much easier to do it on the board. Let me just align the other one. Technology. All right, that's a line there. That's pretty good. I see what happened. My problem was me drawing it wrong. Here it is. So notice what happens when I try to figure out that area. All I gotta do is just erase this piece here in the middle, like that. And I'm left with that piece. How much did I just erase? Half. So all you were supposed to do is, if you want the area in between, all you do is you just take 0.63331 and subtract 0.5. In other words, here's 0.6331. Here's 0.5. Those are the areas to the left. Those are your fees. You just go ahead and just 1,331. And that is the area in between. That's how you find areas in between. So to find the probability of z being less than 0.34, but at the same time greater than 0, you would just take your fees of 0.34 and subtracting your fee of 0.5, of 0.0, sorry, 0.0. I'll just write to be consistent. That's all you do. In other words, the probability of z being less than 0.34 but greater than 0 must equal to the probability of z being less than 0.34 or equal to minus the probability of z being less than or equal to 0. That's another fancy way of writing it, which is just going to be 0.6331 minus 0.5. There we go. Make sense? 5 reasons why some conservatives like Putin. My honest analysis. Well, we all know everybody on the left hates Putin. Yes.
How much does it matter to put less than?
It doesn't matter. Less than or less than or equal to doesn't really matter because equal, that little line has no area. But we should remember that phi means less than or equal to. So when you talk about to the right, it's greater than. Just to keep consistency. Okay, So now let's basically that's pretty much it. But let's talk about how to read this table like for decimal places. Like if I asked you right now, and let me zoom in for you guys to see. If I asked you, let me see something here is more interesting. Let's go up top. Yeah, let's go to the top. It's just better. There's more precision. All right, so if I asked you for the phi of 0.12, you would say what? What's the phi of 0.12? So it'd be 0.5478. Agreed? It'd be I want to highlight it here. 0.5478. Agreed? Oh damn it. It's 0.5478. Now, if I ask you for the phi of 0.123, then what happens is you have to come over here now and you say, fine, I know what 0.12 is, but now I have to go back here and go and highlight this guy all the way over here. You see it? And so now it's 0.5478 plus 0.0012. So now in order to do phi of 0.123, you have to now take 0.5478 and add what that 12, what not 12, 0.0012.
And how can you put it in the like two decimal places after it?
Because that's how we do it.
Okay. And you do that like every time?
Yeah, well, if it's 4, it's 0.0004.
Okay.
It's 4 decimal places. If it's 16, it's 0.0016.
Okay, but basically start writing in the third decimal place.
In this case, yeah, you want to end up with, just remember, whatever is there is either going to be, it means 4 thousandths.
Okay.
Well, 4 tens, hundreds, thousands, 4 10,000s, 12, you know, it depends how you want to say it. And so it's 10, carry the 1, 8, 9, 4, 5, and that's the answer. Yeah. Okay, but again, we're doing this, but obviously it can't be this easy. It is.
So like, you know, 0.123, or like the one, should like start at
Okay, so
5.38.
phi of what? Tell me. Oh, okay, fine.
Same thing for like, we need like the one, be like 0.5.
Well, okay, so first you do this part, which comes out here, right? And then you just add whatever. Does that make sense?
Yeah.
Okay. Okay, so now let's look at some problems from the book, obviously. Because at the end of the day, we want to be able to solve these problems. Okay, up here. So come on, computer, come on. There we go. So here's what I want you to do. I want you to practice this. But I gotta be careful that I don't overwhelm you with so many problems. That's the best way to do it, isn't it? You know what? Let's overwhelm you with so many problems. It's not even that hard. So A, C, D. So I want you to do basically page 142 through 143. 1 through 4, A, C, and E. I'm just trying A, C, and E. I think that would be okay. Let me see. A, C, E, those are good. A, C, E, yes. A, C, E, yes. A, C, E. A, C, E.
1 through 4.
1 through 4. This will be your first grade for next 9 weeks. And I want to do today in class, but I'm going to print out. I have to print out for you guys. And we'll review it in class as well. I mean, the answers are in the back. Oh no. Stop share. Stop the recording.
You will